Welcome back, folks. Today I want to teach you the second of three strategies for finding the solution to a system of equations. It's called the elimination strategy. So I'm going to teach that to you today. Write that as your next title, and after that, close that up, empty those hands, clear out those distractions, and here we go. All right. So last few days here, we've been dealing with like two things equations like this, where you rather than a slope and a y-intercept or an initial value and a rate of change, we're getting just like two things here. So like this one we did the other day, this is like you're buying tacos and burritos, you're buying two things. And those kinds of situations lend themselves to standard forms equations. And yesterday we tried to solve those with a graph, which we did. But as you'll recall, graphing made it really hard to be precise. This was a different question, but when we tried to solve this one with the concert tickets, we made the graphs. You know, we got a point kind of in the middle. It's like, did I draw my line straight enough? Did they intersect exactly there? Is that 7? Is that 8? And I know we're close to the right answer with a graph, but it's not the most precise way to know the exact thing unless you really make a careful graph. So, good news, there are three strategies for finding solutions to systems of equations, and graphing is only one of them. It's a good one. It's very visual. It's very clear. It's very easy to understand, but it's not that precise. And so the other two situations are sometimes better for being more precise. So today we're going to focus on this one called elimination. And it has that name for a reason, and I'll show you in a bit. So here's a problem we've already done before. Ruben buying the popcorn and the drinks, and then Lucia buying the popcorn and the drinks. What was the cost of each one? So we're going to make this our starting one with elimination, and I'm going to write the equations out. Remember, it was 2 times however much a popcorn costs, I'll do P, plus 4 times however much a drink costs, I'll do D, equals $20 for one person. Then the other person bought 2 popcorns and 2 drinks, and that was $14. So here's how the elimination strategy works. What we're going to do is, you'll notice I lined these up, right? P above P, plus above plus, D above D, equal above equal, constant above constant. I lined everything up with its like thing in the other one. What we can do is we can either add or subtract these two equations together. Let's start with adding. If I add these two equations together and just treat them like each thing is like a number that I'm adding, like a multi-digit number. 2p plus 2p would be 4p, plus 2d plus 2d would be 6d, equals 20 plus 14 would be 34. That didn't really do much for me. All I found out is like I basically put these together, and if they, between them they bought 4 popcorns, between them they bought 6 drinks, and between them they spent $34. It just kind of turns their 2 buying equations into 1 buying equation, but that's not, I can't solve that any easier than I can solve anything else. Watch what happens if I go back and instead of adding them, I subtract them. I'm going to start from the right. 20 minus 14 is 6. 4D minus 2D is 2D. And 2P minus 2P is 0. No more P in the bottom one. It's been eliminated. And look what I did. Now I ended up with an equation with only one variable, where it's very easy to figure out the cost of a drink is $3. So by eliminating one variable, by either adding and subtracting the two equations together, then that one's gone, and it makes it really easy to find the other one. Now I know half the answer. Drinks cost $3. And I didn't even have to really do any hard work to figure it out. Pretty cool. So now I know D, but that doesn't help me find P, does it? Well, turns out it does. Because what I can do now is now that I know one of the variables, I can use it to find the other one that I don't know yet. Here's how. I'm going to take that D equals 3, put it back into either equation. It doesn't really matter which one. Either original equation. I'll just choose the top one. And if I put D, now that I know D is 3, I can kind of replace that in that equation with 3. And now look, now I've got an equation with only one variable. And when there's only one variable, I can figure it out. When there's two, I can't. When there's one, I can. So now I'm left with this equation 2p plus 12 equals 20. I can figure out p from there. I actually could common sense it right now and look and say, okay, 12, I need this to be 8, which means p has to be 4. 2 times 4 is 8, plus 12 is 20. But if you couldn't common sense it, you can still solve it. You don't even have to, be able to common sense it. Once there's one variable, we have algebra skills to solve that equation. So I would take 12 away from both sides. That's eliminated. 2p equals 8, and now I can tell that p equals 4. Now I've got my full solution. Pretty fancy, right? You combine the equations to get rid of one variable, and then once you know one, you use that to figure out the other. Pretty cool. It works well in slope-intercept form as well. It actually always works great in slope-intercept form, because check this out. Remember how this works. I'm either going to add or subtract these. I'm going to figure out which one eliminates a variable. So let's try adding them first. If I add these together, y plus y equals 2y. Negative 3x plus 2x is negative 1x. I can stop there. Nothing was eliminated. Y is still there. X is still there. It doesn't help me out much. But if I subtract them instead of add them, you can see right off the bat, y minus y will be eliminated. And I'll only have one variable left. Y minus y is 0, whatever y is, equals negative 3x minus 2x. Let me not mess that up. Negative 3 minus 2. That's the same as negative 3 plus negative 2. So those will make negative 5x. And 6 minus negative 4. Let me not mess that up either. That's the same as 6 plus positive 4 is 10. So now, by combining those, by subtracting those, y has been eliminated. I only have one variable left, just x. And when I only have one variable, I've got the tools to figure it out. So let's find x here. X is being multiplied and added. So first thing I would do, subtract 10 from both sides, or add negative 10 to both sides. That makes negative 10 equals negative 5x, and I can tell that x equals 2. So, by eliminating y, it's easy to find x halfway home. Once I know x, now I've got to go back and find y. To have the full solution, I need to know what x equals, and I need to know what y equals to be done. That would be a full solution. So, what I do is, I take x, I go back to either original equation, does not matter which one, and I put, now that I know what x is, I put x back into that equation and use it to figure out y. So once I do that, I've got y equals negative 3 times 2, no longer x, because I know it, plus 6. Or I could do the bottom one. It doesn't matter which one. So now I know y equals negative 3 times 2 is negative 6, plus 6, and y equals 0. And I'm done. So we find the first with elimination, and then we find the second using the first. I'm going to do redo along with you on a next video. So if you're watching this on YouTube, head to the next one in the channel, because I'm not about to run out of time, but I will run out of time. If you're watching this on the website, the companion video is right next to this one, and we'll restart there.